Hello everyone, this is Heading Tian. In this video, we are learning chapter 7.5, vectors and the dot product. In this video, we are learning the vectors in the component form. If I have a vector, for example, v, we call this v, I can move it in two-dimensional, three-dimensional, or four-dimensional. I can move it anywhere from Houston to New York. So I cannot change the length of the vector because the length of this vector represents the magnitude of the vector. I cannot change the direction of the vector. And I can move it. For example, I move this one all the way to the xy plane and then put the initial point at the origin and terminal point, this terminal point here. And I know the terminal point is A, comma B. So the terminal point is A, comma B. Can you find the magnitude of the U? So can you find the distance from origin to the terminal end? Yes, we can, because I can see that if I draw a vertical line, and then what is the vertical component of the vector u? So I draw a vertical line. I know the b's value of the endpoint is b. The y's value, the y's value is b. So the length here is b. And how about the distance from here to here? I know the x component is a. So the a is the length of the horizontal component of the vector. And then in this right triangle, I have two sides. Can you find the hypotenuse? Yes, I know that. The hypotenuse squared, or we say magnitude of u squared, equals a squared plus b squared. If a and b, they are given, I can use magnitude of u equals square root of a plus square root of a squared plus b squared. And the u can be written as u equals component a, comma b. We call this component form. You see these two symbols like inequality signs that represent u is not a point. U is a vector. If I say I have a point a, comma b, I use parentheses. But now u is a vector. It has the horizontal component. We say a is the horizontal component and b is vertical component. All right, let's see. We also formed an angle theta. You see from initial, so initial side is the positive x-axis to the terminal side, which is the vector u. We got a theta. And the theta, opposite of the theta is the b. Adjacent of the theta is a. So if I know the endpoint a, comma b, so tangent theta equals b over a. So tangent theta equals b over a, where a is not 0. If a is 0, bottom is undefined. Okay, let's see the first example. Find the magnitude and direction angle for u. Every time when we are solving trig question, if I can draw an image, so do that. So first I will find where is the terminal point. 3, comma, negative 2. So u is a vector. So u is a vector and the component form is 3, comma, negative 2. So from the origin, which is 0, comma, 0, connected to the endpoint 3, comma, negative 2, I got my vector u. And the angle, direction angle is from initial side to the terminal side. This angle is theta. All right, the question asks us, find the magnitude of the direction. I want to find magnitude of u. So we have learned it here. That's the square root of a squared. I think it's too big. Make it smaller. Square root of a squared plus b squared. And we have 3 squared plus negative 2 squared. Simplify that. 9 plus 4, 13. So we have square root of 13. And next step, I need to find the direction angle. Direction angle is the theta. We rotate the counterclockwise. The tangent theta equals, so in previous class we have learned tangent theta equals y over x. And here we do the same. What is the y? -2. What is the x is 3. And also you say, we have learned it here, tangent theta is b over a. B is y's value, a is x value. So it's -2 over 3. And how about the theta? It's asking about theta, not tangent theta. This is not a special angle, so I need to use my calculator. And when I'm using my calculator only gave me the inverse of tangent in these two quadrants, the first quadrant and the fourth quadrant. Fourth quadrant is counterclockwise rotation, so it will give me the angle here. So let's see, what is that angle? So I'm looking for so let me write it here first. So I'm looking for the inverse of tangent, -2 over 3. That's the angle here. Maybe I say this angle, give a name, is alpha. Alpha. So the alpha is second tangent -2 divided by 3, close the parentheses, is -33.69. We say keep one decimal place, -33.7. Is about, negative. -33.7 degree. Is this the value of the theta? No, my calculator only gave me the angle rotated clockwise if the angle in the fourth quadrant. If I'm looking for the actual angle, so let me draw the actual angle from the initial to terminal. How to find this angle? So alpha and theta, they are coterminal angle. They have the same initial side and same terminal side. That means I can add or subtract one full rotation, then I can find the coterminal angle. So alpha is -33.7. So the theta, you see, okay, that is alpha plus 360. So theta equals alpha plus 360 degree. And we have -33.7 degree plus 360 degree. This is 326.3 degree. And maybe some of you will ask, I'm very confused about the coterminal angle. So how about this? If you don't understand the coterminal angle, how about this? My calculator gave me this angle is -33.7 degree. And how about the acute angle of this? I say, if I just say reference angle is always acute angle. We say this must be 33.7 degree. If I'm looking for this angle, so this angle plus 33.7 equals, so theta plus 33.7 equals 360 degree. So theta equals 360 minus the reference angle, which is the 33.7. Remember, reference angle is always be positive angle. So I use one full rotation minus the reference angle. I have the same solution, which is 322.3 degree. All right, let's see the next part, horizontal and vertical component. We talked about the vector. If I have the u equals the component form a comma b. So a is the horizontal component, b is vertical component. But now, if I do not know the a comma b, I know the magnitude of u. I also know the angle theta. So how to find the a comma b, or how to find the u in the component form? Okay, let's see if I have vector u in the first quadrant. And this point is a comma b. So if I divided into the horizontal and vertical component. Horizontal one is A, vertically is B, and this is a U, magnitude of U. So and also the given information is theta. So let's see, what is the cosine theta? So cosine theta equals adjacent over hypotenuse is A over magnitude of U. So theta and magnitude of U, they are given. Isolate the A equals magnitude of U times cosine theta. How about sine theta? Sine theta equals opposite over adjacent. So the B equals magnitude of U times sine theta. All right, if the magnitude of U and the angle theta they are given, I can find my A's value. I can find my B's value. All right, so here is the formula. If the magnitude of U is given and the angle theta they are given, then the A can be represented by not absolute value, magnitude of U times cosine theta, and B can be represented by magnitude of U times sine theta. And then the U in the component form A comma B is magnitude of U times cosine theta, magnitude of U times sine theta. Okay, let's see the example 2. If I have a vector W, it has a magnitude 25.0 and direction angle is 41.7 degree. So every time we can graph the image. So this is the angle, that's acute angle in the first quadrant. And the magnitude is given is 25. How about horizontal and vertical component? I need to write my W into the form like this, A comma B. What is A? What is the B? So A in the formula part we have learned is magnitude of W multiplied by cosine theta. Let's evaluate the value of the A. Is 25 times cosine theta, cosine 41.7 degree. We can use our calculator to find the value. Sorry, where is my calculator? But really bad memory. So 25 times cosine 41.7. 25 times cosine 41.7. Make sure you have the degree mode. If you do not have a degree mode, we can set up the mode in the degree mode. All right, we got 18.66. If we round to one decimal place, we have 18.7. And remember, this is the component of A, so or horizontal component, 18.7. And how about B? B equals magnitude of W times sine theta. So we have 25 0.0 multiplied by sine 41.7 degree. Let's use our calculator. 25 sine 41.7, close the parentheses. I have 16.6. So it's about 16.6. So my W in the component form, it is 18.7, comma 16.7. Oh, sorry, 16.6. All right, let's move on to see next one. Writing vector in the form A, in the component form A comma B. So U is given, okay, so the 5 is the magnitude of U, and the angle is 60. So this is super easy. We just evaluate value. So 5 times cosine 60. What is cosine 60? 1/2. And then 5 times sine 60, square root of 3 over 2. If the question didn't ask you to round it to the decimal places, you can keep the form like 5/2. You don't need to give me 2.5. All right, how about this? So 5 times square root of 3 over 2. That's 5 square root of 3 over 5 times square root of 3 over 2. How about next one? The vector v equals 2 times cosine 180, comma 2 sine 180 degree. Where is 180? Okay, it's here. We talked about this before. If I have my terminal end on the xy axis, so we can use unit circle to solve the cosine sine tangent value. So this point, for the cosine 180, the unit circle point is -1, comma 0. And for the cosine 180 is -1 over 1 is -1. And how about sine 180? Is y over r is 0 over 1. It is 0. Okay, I have 2 times -1. And then comma 2 times 0. So this is -2 comma 0. How about next one? It says round to 4 decimal places. This one, w equals x component 6 times cosine 280 degree. Y component is 6 times sine 280 degree. So this is the one I need to use my calculator because these two, they are not special angles. So how about 6 times, 6 times cosine 280 degree, and hit enter. That's 1.0419. So the horizontal component is 1.0419. 1.0419. And the y component, let's use 6 times sine 280 degree. 6 sine 280, close the parentheses. That's -5.9088. Yes, so it doesn't matter you have a negative value. So -5.9088. All right, we're done. Let's see next part. Vector operations. If I have the let the a, b, c, d, and k represent the real numbers. They could be any real numbers. And the first vector a comma b plus second vector c comma d. Then I will have the horizontal component plus horizontal component a plus c comma b plus d. You see, a plus c comma b plus d. So the sum of two vectors is also a vector. How about the k? The scalar k is a real number times a comma b. That means maybe I stretch my I stretch my vector, or I compress my vector. So I can distribute the k inside of the vector. Multiply by a, multiply by b. I have k times a comma k times b. If the u equals a sub 1 b comma a sub 2, then negative u is negative a sub 1 comma negative a sub 2. So I can distribute the negative sign inside of the parentheses. So I have negative, then I distribute the negative sign in the parentheses. All the component, they becomes opposite. Next one is a subtraction. Actually, subtraction is very simple. You subtract the horizontal component, you subtract the vertical component. You are having a minus c comma b minus d. You can also think it in the addition way. So we can say addition. So subtraction means add negative. So we can say a plus negative c, b comma b plus negative d. Okay, let's see the first example. Example 4. Let's u equals -2, 1, v equals 4, 3. Find u plus v. So x plus x, or the first horizontal component plus horizontal component. I'm having -2 plus 4, y plus y, 1 plus 3. I'm having +2, 4. All right, let's see next one. -2 times u. So -2 times -2, 1. We can distribute the -2 inside of the vector. So I'm having -2 times -2, -2 times 1. We have 4, -2. How about next one? 3u minus 2v. What is 3u? 3 times -2, 1 minus 2 times 4, 3. So do the distribution first. Multiplication goes first. I'm having -6, 3 minus 8, 6. Do the subtraction. -6 minus 8, 3 minus 6. So we are having -14, -3. Let's see, next part is unit vector. A unit vector is a vector that has magnitude 1. And two very important unit vectors are defined as the following. So we are not only having one unit vector. So this is also a unit vector, for example. The length is 1. And the two special unit vector, we call them I and j. So the I is a horizontal unit vector. So the x value is 1, y's value is 0, because the length is 1. And the vertical unit vector we call j is 0, 1. So all the vector can be rewrite into the form I and g, or rewrite into with the unit vector. So if I have a vector a, b, so if I have a vector a, b, and in the form of the unit vector, I say, so that is ai, a times the first vector I, plus bj, so b times the vertical unit vector j. So every time you see a, b, that is ai plus bj. This is another form to write the vector. So if I have a vector 3, 4, then in the unit vector form, I'm having 3i plus 4j. Okay, let's see. Oh, okay, here has the explanation. This is I and j. So 3i means 3 times I. So the I multiplied by 3 times, stretch 3 times. And for the y part, 4j, you stretch the unit vector j into 4j. So the u is from initial to terminal. Endpoint is 3, 4. Okay, let's see the first example. How to add or subtract the u and v, or vectors, in the unit vector form. So I will add all the x together, or all the I part put together, plus j. So if I have u plus v, so I'm using this I plus 5i, I plus 5i. This is the I part, plus this is addition, plus j plus -3j, or use brackets. Then do the simplification. Let's erase this. We have 6i plus -2j. So this is 6i minus 2j. How about u minus v? So let's see. U is use I minus 5i. So the I part is I minus 5I. And the j part is plus. So we always have I plus j. So this is I part plus j part plus j plus j minus negative 3j. So we have negative 4i plus what's inside. We have j plus 3j is 4j. We have negative 4i plus 4j. Okay, let's see next. We combine all the I together, j together. Let's find what is negative 4u first. Negative 4u, negative 4 times I plus j. We can distribute the negative 4 first. Plus 3v, 3 times v. What is v? 5i minus 3j. We are having negative 4i minus 4j plus 15i minus 9j. Combine like terms, I terms together, j terms together. We are having 11i minus 13j. Okay, so for example, you say, I still prefer in the previous method I have learned in the component form, u equals 1, 1. Because I means the axis component or horizontal component. J means horizontal component. V equals 5, negative 3. Then we do the operations. We do addition, add all the x together, and I add all the y together. You can convert it to the component form. All right, let's learn a new concept that's the dot product. We also say this is a scalar product. Dot product and angle between vectors. Dot product of two vectors is a real number, not a vector. So the solution of the dot product must be a scalar or a real number. It is not a vector. So let's see, dot product. The dot product of two vectors, u equals a comma b and v equals c comma d, is denoted as u dot v. We say u dot v, and given by the following: u dot v equals a times c plus b times d. You use the horizontal component to do the multiplication plus the multiplication between b and d. And then let's see, the solution must be a real number because a plus times c plus b times d is a number. My kids is crying outside. All right, let's see example 6. Find each product. So by the formula, we know the dot product between two vectors. We multiply the horizontal component together, 3.4. Then we plus, so here is always addition, plus 3 times negative 1. Then we have 12 minus 3. This is 9. So the solution is 9. And how about next one? The dot product between two vectors, 6.2, and plus 4 times 3. So we have negative 12 plus 12. Oh, I got 0. So let's move on to see the properties of the dot product. So if I have u dot v, that equals v dot u. If I have u dot v plus w, then I can distribute my u inside of the parentheses. U dot v plus u dot w. U plus v dot w equals u dot w plus v dot w. And k times u times, dot v. So k is a scalar here, is not a vector. So I can pull out the k outside and do the dot product between u and v equals u dot kv. And 0 dot u equals 0. U dot u is magnitude of u squared. So these are the properties. You will also learn these in the calculus. I think in calculus 3, you will learn it again. So let's see the dot product. Let u equals 3, 4, v is negative 2, 6, w is 1, negative 1. Find each of following, make it bigger. So u dot 2w, so we will see what is a 2w. So u is 3, 4. Dot 2w. So let's find 2w first. 2 times 1, negative 1. So it's 3, 4. Dot 2, negative 2. The dot product is 3 times 2 plus 4 times negative 2. This is 6 minus 8. This is negative 2. How about next one? So parentheses goes first, right? So let's do the parentheses. That equals, in the parentheses, I have the 3, 4 minus negative 2, 6. Then do the dot product, 1, negative 1. And in the parentheses, let's do the subtraction. 3 minus negative 2 is 3 plus 2. And then the y part, or the vertical part, is 4 minus 6, negative 2. Dot product, 1, negative 1. I didn't simplify the first part. Okay, that is 5, negative 2. Dot product, dot 1, negative 1. We have 5 times 1, 5, plus negative 2 times negative 1 is 5 plus 2. It is 7. And next, let's see, u dot v. So u dot v in the parentheses goes first. So u is 3, 4. Dot v, negative 2, 6. And then we do the dot product first, minus u dot w. So let's see. That's 3 dot 4 dot 1, negative 1. Okay, let's do the dot product in the first parentheses. Negative 6 plus 4 times 6, 24. And then minus, in the parentheses, I'm having 3 times 1, 3. Plus 4 times negative 1, negative 4. Okay. Minus 4. Let's do the computation. We have 18. Minus 3 minus 4, negative 1, plus 1. So we have 19. So we solved this dot product problem. Okay, let's see next part. Geometric interpretation of dot product. So if I have two vectors, u and v, how to find the angle between these two vectors? So in the previous class, we have learned that so in the previous class, we find the sum of two vectors. But now, if I'm not finding the sum of two vectors, I'm looking for this angle theta. In the sum of the two vectors, we know that I can move one of the vector to here. And then find the sum first. So I construct a triangle. So I can find maybe the angle here. And then, the angle is given between them. And then I can solve the sum of the two vectors. But now, the angle between them, they are not given. How to find this theta? Or how to find this angle between these two? We got a new formula. We have cosine theta equals u dot v divided by magnitude of u times magnitude of v. Okay, let's see. If I have, let me ask you, if I have two vectors, this is v, this is u, this is the angle between v and u. So the theta could be acute angle or obtuse angle. Could be like this, v and u. So it could be this. So can I have the angle that is obtuse? No, we will not. So not obtuse is more than 180. No, we will not do this. The greatest value, the angle between these two vectors, v and u, they are opposite direction, and this angle is 180. If I have this is v, this is u, and the angle is here, I will not measure this angle because these two vectors, the angle between them must be between 0 and 180. The greatest value of the angle is 180 degree. So I will not measure this because this angle and this angle, I prefer to have a smaller angle, and also that's represent the angle between these two vectors. Okay, let's see. Let's use this formula to find the angle between the vector u and v. And also we need to be very, very careful. When we are looking for the theta, we need to use the theta equals the inverse of cosine of this. So if I'm having a positive value, for the cosine, the inverse function, my calculator will give me the angle in these two quadrants. For the cosine, if I have a positive value cosine, the cosine value is positive, then I'm having acute angle because if this value is positive, my angle in the first quadrant, that's acute angle. If here, my dot product, the solution here is negative, then my angle in the second quadrant, so the angle is obtuse. When the theta is, when I got 0, so inverse of cosine 0, it is 90 degree. So this is a right angle. Okay, let's see. The first example, find the angle between the two vectors, round to 2 decimal places. So the angle cosine theta in the cosine equals, equals u dot v. It doesn't matter which one goes first. All divided by magnitude of u times magnitude of v. And then let's input the data. So u dot v is 3.4 dot 2.1, 2,1. And how to find the magnitude of u and v? So the magnitude of u equals square root of a squared plus b squared, which is 3, 4. So square root of 3 squared plus 4 squared, this is 5. The bottom is 5. Then what is the magnitude of v? That's square root of 2 squared plus 1 squared. It is square root of 5. So 5 times square root of 5. That's the bottom. And then on the top, let's do the dot product. That's 3 times 2, 6, plus 4 times 1, 4. The top is 10. So we have 10 over 5 over square root of 5. Do the simplification. I have 2 over square root of 5. So am I done? Or you say rationalize the expression. But we are looking for what? Angle. We are not looking for the cosine theta's value. So what is theta? So now I know that this must be the acute angle because this is the positive value, and also my angle of between the two vectors between 0 and 180 in these two quadrants. Positive, we must have the acute angle in the first quadrant. Theta equals the inverse of 2 over square root of 5. let's use our calculator to do the computation. Okay. Inverse. So second cosine, inverse of 2 divided by root 5, square root 5. Close, move the cursor, close the parentheses. Hit enter, so I got 26.57. So let's round to 2 decimal places. Yes, because the question says 2 decimal places. So it's about 26.57 degree. Okay, let's see next example. I'm looking for the theta, but before we said in the formula we have u dot v. Also we have magnitude multiplication between u and v. Maybe we can find the magnitude of u and v first. Magnitude of u equals 2 squared plus -6 squared. And then this is 4 plus 36, that's square root of 40. This is 2 square root of 10. Because let's do review. 40, square root of 40 equals square root of 4 times 10. I can separate the 40 and 10. And square root of 4 is 2 square root of 10. So that's how I got 2 square root of 10. How about magnitude of v? That's square root of 6 squared plus 2 squared. That is 36 plus 2. Oh, they have the same magnitude, I feel. Plus 4. Square root of 40. This is 2 square root of 10. And then let's find the cosine theta. Cosine theta between the two vectors, 2, -6 dot 6, 2. And all divided by, the magnitude of u, 2 square root of 10 times 2 square root of 10. And what is the top? Top we have 2 times 6, 12, plus -12. The bottom is 4 times 10 is 40. And the top is 0. So cosine theta equals 0. What is the cosine? So for the cosine, all cosine equals 0, the cosine theta equals 90 degree. So theta equals 90 degree. Maybe you will ask me, how did you find this? So my angle must be between these two quadrants from 0 to 180 degree. And the cosine cosine theta equals 0, so that is the y's value equals 1 and x value equals 0, because 0, okay, this point 0, 1, because first one we say cosine theta and comma sine theta. So first one is 0, cosine theta is 0, so here is 0. The angle there is 90 degree. Also, you can use your calculator to do this. So inverse of cosine 0, close the parentheses, 90 degree. All right, we found the theta is 90 degree. Let's see next one. Okay. All right, it gives us the u and the v in the unit vector form. Oh, that means if I don't like to have the unit vector form, I can convert it to have my u in the component form is 1, 5. And v equals 2, 10. So the magnitude of u equals 1 squared plus 5 squared is square root of 26. And the v, magnitude of v is 2 squared plus 10 squared. It is square root of 4 plus 100, 104. So I got magnitude of u and v. And the formula of finding the cosine theta is u times v, u dot v, 1, 5 dot 2, 10. All divided by square root of 26 times square root of 106. 104. And then do the dot product on the top. I got 2 plus 50, 52. And the bottom is 26 times 104. We got 52 over square root of 26 times 104. 2704. 2704. How to simplify this? So let's try if I can find the square root of 2704. What is square root of 2704? Oh, 52. That's perfect. So we have 52 over 52. It is 1. And looking for the cosine, theta equals 1. And what is the cosine? What is the theta? So cosine theta equals 1. Cosine theta, you can also use a unit circle. Cosine equals x over r. R in the unit circle is 1. So x equals 1. Where is the value x equals 1 on the unit circle? It's here. Is 1, 0. So theta equals 0 degree. You cannot say 360 because for the vector, the angle between two vectors is between 0 and 180 degree. You cannot have 360. Okay, so we are done for this question. Let's see next one. Oh, we do not have next example. All right, we're done. So we're done for the chapter 7. So we're having the final exam very close to us. Please be prepared and have a good one. If you have any question, let me know. Bye-bye.